Hi, I'm Elliot Kennel from the Cameron Group. We are a group of consultants that provide solutions to very difficult problems. I think one of the most difficult problems that we face as a society is that of global warming, which is going to be something that we face for the balance of this century for the next, let's say, 75 years till the year 2100. Our company provides solutions. We don't just worry about things and assign blame. I actually want to solve global warming and restore the Earth to the condition that we think it should be, rather than just complain about how terrible things are and wait for the world to end due to carbon dioxide heat death. That's not the right answer. We are going to solve this problem. I believe the resources will be in place. And I believe the technology will be in place. And I'll explain why I think this way with the attached presentation. And let's see if we can make that work. Here we go. Okay, so as I said, I believe high tech will provide answers to climate solutions. I don't believe they're going to be simple solutions. I don't believe they're going to be easy. I don't think you're just going to vote for a different political candidate and solve all your problems. It's not going to be like that. It's going to be something that's going to be sustained. It's going to take the inputs from both left and right in America, Democrats and Republicans, and around the world. And it's going to take some new thinking, some original thinkers, solutions that haven't been conceived of yet. I'm sure that we can do this. I refuse to believe that we're going to work on a problem for 75 years and not think of something new. That doesn't make sense to me. We are going to win. We are going to solve this. Our great grandchildren are going to be just fine. First, though, global warming is not intuitive. I think part of our problem is that we are surface dwellers. We're used to thinking about the planet in terms of things that happen at sea level or maybe a few hundred feet above sea level, but that's what we think of as the planet is the surface. But global warming is an atmospheric phenomenon rather than a surface phenomenon. And so I'm going to do a little bit of planetary education for a few minutes and then come back to the planet Earth. Let's start out with Hawaii. What's the temperature of Maui? You may say that it's 85 degrees Fahrenheit because you're fixated on sea level, and that's where the temperature is. At sea level, it's 85 degrees. But I could say, well, I've been to the top of Mount Haleakala and it's really cold up there. It's about 50 degrees Fahrenheit because it's 3,000 meters high or 10,000 feet. The simple fact is that the higher up you go, the colder it gets. And the reason is there's just not as much energy contained in the gas as it's thinner and thinner. Down below, the lower layers of the atmosphere have to support the upper layers. So things are denser. There's more atoms, more molecules that are in there colliding. And that means energy. That energy of molecules banging into each other is what constitutes energy and heat. So, by the way, if you were to dig a hole 10,000 feet deep and then measure the temperature there, you'd find that it's going to be about 35 degrees hotter down at the bottom of that hole than at the surface for the same reason. It's going to be denser, the pressure will be higher, and therefore the temperature will be higher. So I want to turn now to Venus because we're not as emotionally attached to it, and maybe we can think about that in a little bit different way. How hot is Venus? Now, you may say, well, look it up in the textbook. It's 462 degrees Celsius and 1350 psi. That's about 90 atmospheres. But again, you're thinking about this in terms of a surface problem. But I could say if I had a balloon and I'm above the sulfur dioxide and sulfuric acid clouds, it's actually 20 degrees Celsius up there. It's room temperature and it's 14.7 psi, 1 atmosphere. If you're up 53 kilometers above the surface of the planet. Now, that's a big difference. Way down low, it's very, very hot. But if you go up high enough, it cools down and it's actually rather cool planet. And in fact, in the 19th century, they looked at the planet with telescopes and they thought, this planet probably reflects a lot of sunlight. Maybe it doesn't get that warm in Venus, even though it's closer to the sun. We think it might actually be a little cooler than the planet Earth. I wonder if it supports life, just like here. Maybe Venus is very Earth-like. Later, they found out how thick the atmosphere really is, and they realized that it had to be much, much hotter. But that came as a surprise. That was not intuitive. And this photo credit, by the way, goes to the Jet Propulsion Laboratory in NASA, who are thinking about ways to discover or to investigate the planet Venus and others with hot air balloons. Okay, so Earth's surface, by the same token, does not radiate energy to space. It doesn't go from the the ground or the sea level and go all the way to outer space. There is no photon at the appropriate temperature that can do that. Now, you can reflect optical light from the sun and have that go into outer space, but these infrared or photons, excuse me, um, don't make it very far. You have to go up about 5 kilometers, and at that point, the air is thin enough that a infrared photon emitted from CO2 can make it all the way to outer space without colliding with something else. So that's the effective radiating level. It's about 5,000 meters high, and even much higher than Mount Haleakala, and it's cold there. The average temperature of the Earth is about 0 degrees Fahrenheit. It's a it's cold. There we go. This graph shows the temperature of Earth and what happens if CO2 levels go up. This blue line shows that the temperature is warm at zero elevation. As you go higher and higher, it becomes colder and colder until it's like minus 18, which is pretty cold. That's about 0 degrees Fahrenheit. But if you add carbon dioxide, the planet has to cool itself from a higher altitude. So, in other words, a greater distance from the radiating level and then the Earth's surface. And so the Earth's surface is going to have to warm up in order to compensate. It may take days, weeks, or I don't know what the time constant is, but it has to be warmer in order to compensate for the additional carbon dioxide in the atmosphere. And so I'm showing that a 40 parts per million CO2 increase, that's about the same that the world experienced between the year 2000 and 2025, is going to result in about 1.5 degrees Celsius um, increased temperature, and it's also going to change the effective radiating level from 5,000 meters to 5,150. So that's what's going on here. The the radiating temperature of the Earth is going to be down here, and it's going to stay about the same, but as a consequence, down at the sea level, it's going to be a degree or a degree and a half warmer. That's why it gets warm. The Earth is radiating its heat from a higher altitude when there's more CO2 present. It's trying to become more like Venus, in other words. All right, so let's pause. What have we shown with this little argument? What have we not shown? One is that the excess CO2 has to result in a somewhat higher global temperature because the thermal radiation has to occur from a higher altitude. There's more CO2. It's going to happen further out than if there's less. Now, however, we did not show that the problem is huge or that it's small or that it's a disaster waiting to happen or that the polar bears are going to die. We didn't show any of that. That remains to be discussed. But one point I do want to make is that this is not a crisis in the sense that it can be solved immediately today or next week or even at the next election. It's going to be decades of constant study, battle, and uh, remediation activity in order to control the temperature of the planet. This is an interesting graph. What this shows is for several countries, namely Germany, United States down here at the bottom, and then Russia and China up at the top. It plots how much CO2 is emitted per dollar of GDP. And these efficient economies like United States and especially Germany are very good at not producing very much CO2, whereas the countries that are not as efficient, namely Russia and China, produce a lot of CO2 for every dollar of GDP that they produce. The trend is that we're getting better and better. It doesn't matter whether we had a Democratic um, presidential uh, candidate or whether it was Republican. It's been getting better since 2020, and we're reducing the amount of CO2 that we emit. And same with Germany. They've been very aggressive about implementing pro-environmental policies, and it shows that, in fact, their economy is very good at avoiding the emission of carbon dioxide. So I don't think that we really want to emulate Russia or China, make our economy more like theirs, reduce the GDP in hopes that that's going to fix the CO2 problem. I don't think it's going to be fixed at all. I think you're going to make it worse. If you make the economy worse, the efficiency is going to go down and you're going to emit more carbon dioxide. Don't think that's what we really want to do. This I call the Change Your Global Outlook in One chart. And let me just tell a little story that there's a friend of mine who was a student at Wright State, and he's much younger than me, like in his early 20s, and he's complaining to me that, gee, Elliot, your generation made progress the whole time during your working career, and you got to see electronic things be invented, all kinds of wonderful things happened in your lifetime. But now in my generation, everything is going to stagnate and we're just going to have to fight to maintain our standard of living for the rest of our lives. Well, gosh, I really wanted to shed a tear for the young fellow, but I said, you know what? I can change your outlook with one illustration, with one graph. And he said, oh, no, you can't. And I said, yes, I can. And then I showed him this graph up here on the left, which simply plots the gross domestic product per capita. This is per capita, by the way, not per nation or for the world, but per each individual. And what it shows is that it's really taken off at an exponential rate with the Industrial Revolution in the 1700s and has just accelerated forward. Every economist understands that economies grow at an exponential rate. And being trying to shut this off, I think, is a fool's errand. That is simply not going to work. But we have all this money that's going to be created in the next several years, and some of that can be used to provide environmental solutions. I don't think global warming is the only problem, or that CO2 is the only problem that we face. There's a number of environmental issues that need to be addressed, and it's going to require a lot of resources in order to do it. So what are the solutions? Well, the specific solutions, if I really knew, I'd invent them and I'd be rich. But I know that I don't know. I do know that the year 2100 will see much more advanced technology than we have in 2025. The climate, it's not going to be corrected quickly. It's going to be a sustained effort. But here are three possibilities that I list. One is that the physical extraction of CO2 is technically reasonable today, but financially not. But 75 years from now, we might reverse that conclusion and decide that, yeah, it really does pay to remove carbon dioxide from the atmosphere. Let's go build us some gigantic facilities and actually do that. Hypothesis two, it may be possible to change the Earth's albedo, or the reflection of sunlight in the upper atmosphere, by the modification of clouds. Maybe we could seed the clouds or find some other chemicals that interact with sunlight in a special way so that the sunlight does not warm the earth, does not come all the way to the ground and warm the earth up. Third, I'm very concerned about the whale cycle. It used to be before the age of whaling. There was a very interesting cycle between phytoplankton, krill, and whales, in which the krill ate the phytoplankton, the whales ate the krill, and then the whale poop fertilized more phytoplankton. And so it was a very a good self-contained ecocycle, and it was severely damaged by whaling in the 1700s and 1800s especially, and it's never come back. Maybe we ought to fix that. So we spend a lot of time worrying about the well-being of our great grandchildren, and I think we should worry about future generations. However, solutions that seem unaffordable today could very well be affordable in the future, especially if we believe that the society is going to grow economically, just as societies have grown at an exponential rate for thousands of years. This is science just as much as climatology is science. Economists know that economies grow at an exponential rate. Also, I want to point out once again that the people of the year 2100 will have the benefit of 75 years of intense research on how to wisely solve climate problems. And I have no doubt that they'll be able to do a better job in the future than they can do now. Finally, let me leave you with this question is, do you believe, okay, there's all these rich people that own way too much property and, but they're still greedy and they still own all this stuff. But are they going to sit idly by and watch it be destroyed by climate change and they're not going to put up a fight? That I find very hard to believe. I have to believe that they will get together and they're going to preserve the wealth of the world, if for no other higher purpose than the greed principle. They are not going to let the earth be destroyed by this problem. It's going to be solved. So that's what I had to say. I hope that you enjoyed it. Please feel free to add your comments down below and subscribe. Take care, everybody, and God bless. Bye bye.